Okay, so I'm very pleased to be welcoming Chris Knight on stage with me now. Beckhoff UK XTS product specialist.
That's the one.
Got that right, okay,
Yep.
Fantastic. So we just looked at high drive and now we're going to switch to the opposite end of the scale, looking at the Agile system, which is really all about high dynamics with low load type applications. So what this is all about is basically we've looked at Newton's second law of motion, which is force equals mass times acceleration. So what we've done is basically chopped out loads of mass so we can actually increase the acceleration. So the smallest standard HepCo mover that we do on the standard XTS is 610 grams. The Agile mover has dropped right down to 250 grams. How have we done that? Okay, so we've got a smaller bodied mover. It's lower. We've included lots of machining in the body, so we've taken material out as much as we can without compromising the stiffness or strength of the mover. And we've also developed a smaller diameter bearing, so it has lower inertia, allowing us to basically spin it up quicker and achieve higher accelerations. So what does this mean in terms of actual performance? Linear speeds of 6 meters per second and decelerations of about 20 G. So this is really sort of maximised performance, isn't it, Chris?
Absolutely. Does any of that affect the actual track that it runs on?
So no, the track that we use, and I'm pointing to the track management system there, but the Agile system uses exactly the same track itself as the standard XTS, but there is a small difference in terms of how we mount your XTS motors. Okay. Because it's a smaller mover, we've actually had to adjust the height of your motors. But fundamentally, the principle is exactly the same. So in terms of actually driving these movers, what sort of challenges does it present to you, and you know, how does it affect the accuracy and repeatability by stop and starting much quicker?
I mean, in principle, it doesn't actually affect an awful lot of what you do when you configure an XTS system. So you still use the exact same twin cat operating system, you still use the exact same XTS configurator, and you use the exact same PLC code to actually drive the movers around, as we said, independently of each other. What has changed because of the mechanical changes you've made is obviously the acceleration switch you can go, so you have to be a lot more careful with how you're starting and stopping things, but you still maintain the repeatability, even in that condition. And you have to be aware that the systems can run much closer together. So this is another main benefit of this system, is we can actually run them now with a 55mm pitch between two mover centers. So you can gather those movers together incredibly close, should you have to, for a particular machining application. We use the 4-pole magnet system on this mover, which means that you're using less force, so you've only got 70 newtons. But that still means that you're reducing the amount of energy consumption of your system while maintaining those high accelerations and decelerations, as you say. Okay,
so this is the eco-friendly version of the XTS then. So yeah, obviously we are at the opposite end of the scale from the high drive. So the payload is very much reduced. We're aiming at sort of maximum payloads of up to 250 grams. So this is really sort of aimed at applications, high yield, low mass, so something like a plastic syringe body, manufacture blister packs in pharmaceuticals, small lightweight cosmetics, where you really want to maximize your throughput of the product through the system. You know, because effectively when you think about it, when you're transferring your product from one process station to another, that's all lost time. It's dead time, Absolutely. Dead money. So you want to throw it out as fast as possible. In terms of actual sort of throughput, we are looking at numbers of say 500 to 800 parts per minute if we're indexing. Continuous motion, 1,000. Yeah. So we're really shifting with this system.